we're going to go ahead and go over how to create a linear regression line in Desmos. So I have number 15 pulled up from our 10.2 practice. And I'm also going to go ahead and access desmos.com. Remember, it's not student.desmos, it is just regular desmos.com. You'll click on Graphing Calculator. And as we go through these steps, I encourage you to try them with me, and feel free to pause the video after each step to make sure that you can also complete them as well. Our first thing we're going to do is click on the plus and add a table. We're going to go ahead and type all of our data into the table so that Desmos will graph it for us. Okay, so I have left off the last value because 8.6 we're actually going to use for a prediction. So if we go back and look at our textbook, we know that we do need to create a linear regression line equation. So I'm going to go ahead and highlight what we need to do here. We need to find the equation for the line of best fit. And we also need to find the correlation coefficient, and we're going to interpret it. And then we're going to use the line of best fit to estimate the average temperature of another city. So that's going to be our 8.6 that we are going to estimate on this table. So we're looking for our line of best fit first. So I have my data in the table. Now I'm going to click on the plus button to add an expression. And we need to make sure we are using the same notation as our table. So notice how it says x1, y1. When we write our equation, we also need to use x1 and y1 to make sure that Desmos is talking to the right data. So to type that in, we type in y and then the number 1. It'll automatically make it a sub 1. And then we're going to type in tilde, which is shift, and the button next to the number 1 button on your keyboard. M, then x1 plus b. So we have some values here. We'll talk about these in a few moments. The first thing I notice is that I don't see any of my data or my line. And then I look over here at my window and I notice that my range, my domain here is not big enough for my data, which goes up to 50. So I need to make my window a little larger. And the same thing for my range here as well. It goes all the way up to 58, and this only goes up to 10. So I can zoom out by clicking the negative button. And now I can see my data and my line. So you can see the green dots. If your green dots are not showing up, make sure this circle over here is filled in, because if we click it, it will turn our dots on and off. So see how my circle is empty? I have no dots here. If I click it again, then it plots all of my points. Same thing with my graph. If I click on that, it'll make my circle empty. Click it again, and it will give me a black line. So I've been given my linear regression line. I can tell that my slope is down here, negative 0.945644, and my y-intercept is 71.1485. So I'm going to go ahead and round those because I don't need that many decimal places. I'm going to round to the nearest hundredth, which is 2 places, and I'm going to rewrite my equation over here on my bookwork. So I need to write my equation for my line of fit. So it's y equals m, and m is negative 0.85. I'm going to round, so round to 2 places, x plus b, which is 71.15. So I have my slope that I've gotten from my linear regression line. I also have 71 that I got as my y-intercept, and that is my line of regression. So now the next thing I need to do is find my correlation coefficient, and that is also over here in Desmos. So I used M, I used B. Now under statistics, I can find my correlation coefficient, which is just R. So let's see, I'll go ahead and label that here. My correlation coefficient is R equals negative 0.9969. And what that means is this is a really good fit for my data. So I notice that my line is really close to all of my points, and that also, so that tells me one way I can tell it's a good fit. And then also my correlation coefficient, I know if it's really close to +1, it's a good fit, or if it's really close to -1, it's a good fit. So since I can see it's very, very, very close here to -1, what that tells me is it's a downhill slope. So it's a negative correlation, and it's a really strong fit. So I'm going to go ahead and type that in here. So I have our line of fit. So we have a good line of fit. And we have a strong negative correlation. So when we talk about correlation, we use the words weak or strong, depending on how close it is to 1 or -1. Okay? Now the next thing we have to do is estimate the average temperature for this city that's given here. So I have 8.6 as the location of Panama City, and then I'm going to use my data and I'm going to use my model to find out what the average, to estimate the average temperature. So we're not just going to do this from our graph, like estimating kind of like, oh, about this value. We're going to actually type it into our equation, and we can get it that way. So I'll put, let me label my work here so you know what I'm doing. I'm finding the average temp for 8.6, and it's degrees north. And what I'll do is I'm going to type into the equation that x equals 8.6. How do I know that x equals 8.6? I know that because latitude is my x. Remember in my table, all of these values for x are the latitude values. And then my y is my average temperature. So what I can do is substitute in this my latitude to my equation, and then I will actually calculate my average temperature. So y equals -0.95, and then instead of writing x, I will replace it with 8.6 for x, and then I'm going to add 71.15. Let me get that equation over there so you guys can see it. So now what I can do is find the next value of my line. So I'm just going to type that into my calculator. So I get 62.98, which is about 63 degrees Fahrenheit. So my average temperature down here, I can write in 63 degrees for Panama City, Panama.